Imagine electricity flowing through a wire with almost no energy lost as heat. That is what a superconductor can do. Normally, electricity travels through metals like copper or aluminum, but electrons keep interacting with atoms inside the material. That creates electrical resistance, and some energy is lost as heat. A superconductor works differently. When certain materials become cold enough, their resistance suddenly drops to almost zero. The electrons begin moving together in a special quantum state. In simple terms, electricity can keep flowing with almost no energy wasted inside the wire. This effect was first discovered in 1911, when physicist Heike Kamerlingh Onnes cooled mercury to extremely low temperatures. Its resistance suddenly disappeared, and this could make a huge difference in real life. Across a normal electricity network, roughly 10% of electricity can be lost between power stations and customers through transmission and distribution. So if a power station produces 100 units of electricity, perhaps only around 90 units effectively reach us after the full journey. A superconducting cable could reduce the resistive loss inside the cable to almost zero. Another example is MRI machines. Normal powerful electromagnets can use a lot of electricity and create heat, but MRI machines commonly use superconducting magnets. Once the current is flowing inside the superconducting coil, it can continue with almost no resistance. Superconductors can also push magnetic fields away. This is called the Meissner effect. It is why magnets can appear to float above them. But there is one major problem. Most superconductors only work at extremely low temperatures. Some need temperatures close to minus 269 degrees Celsius. That means expensive cooling systems. In 1986, scientists discovered new ceramic superconductors that worked at higher temperatures. Still very cold. But some could be cooled using liquid nitrogen. Since then, scientists have been searching for the ultimate breakthrough, a superconductor that works at room temperature and normal pressure. In 2023, a material called LK99 created worldwide excitement. Some claimed it could do exactly that, but after laboratories around the world tested it, the claim was not confirmed. So the search continues. But imagine if we finally succeed. Electricity could travel much farther with far less waste. Electric motors could become smaller and stronger. Electric cars could become more efficient. High-speed trains could float above their tracks with very little friction. MRI machines could become smaller and cheaper. And stronger magnets could help technologies such as nuclear fusion. Our power grid could also become much more efficient. Solar and wind energy produced far away could be sent to cities with much less electricity lost along the way. So in daily life, we could have cheaper energy, better transport, smaller machines, and cleaner cities. The biggest change may be something we do not even notice. Today, part of the electricity we produce is simply lost before we can use it. If room temperature superconductors become possible, much more of that electricity could actually reach us. And that could change the way we power almost everything around us.